We want to find a possible equation for a polynomial function with real coefficients having zeros -4, -1, and +3. Let's review what we know about the zeros of a polynomial function. First, the zeros or roots of a polynomial function are the x values for which f of x is equal to 0. So they're the values of x that make the function equal to 0. If the zeros or roots are r sub 1, r sub 2, and so on, this gives us information about factors of the polynomial function. If r sub 1 is a 0, then x minus r sub 1 would have to be a factor of the function. If r sub 2 is a 0, then x minus r sub 2 would also be a factor of the polynomial function, and so on. Notice how there's also this a out here. A can be any constant. Notice how it's not going to affect the zeros of the function. However, we'll always let a equal 1 unless r is a fraction. If the polynomial function has complex zeros or roots, these always come in conjugate pairs. And then lastly, graphically, if we have real zeros, the real zeros would be the x-intercepts of the graph of the function. So going back to our problem, if we know these are our zeros, this gives us information about the factors of a possible function. So f of x, our function, would have to have a factor of x minus -4 if -4 is a 0. If -1 is a 0, our function must have a factor of x minus -1. And if +3 is a 0, then we'd have to have a factor of x minus 3. Again, we could put a constant here, but since we don't have any fractions, we'll go ahead and let a equal 1. So now we're going to simplify our binomial factors and then find this product. So f of x is going to be equal to, we have a factor of x plus 4, a factor of x plus 1, and a factor of x minus 3. Now to multiply this out, there's no shortcut. We can only multiply two binomials at a time. So we'll multiply the quantity x plus 4 times the quantity x plus 1, so we'll have 4 products, 1, 2, 3, and 4. So we'll have f of x equals x times x, that's x squared, x times 1, that's 1x, and then we have 4 times x, that's 4x. 1x plus 4x is 5x, and then 4 times 1 is +4. So we have this trinomial times the binomial x minus 3. Multiplying these two, we'll have 6 products, 1, 2, 3, 4, 5, and 6. So we'll have f of x equals x to the second times x, that's x to the third. X to the second times -3, that's -3x squared, or minus 3x squared. Then we'll have 5x times x, that's 5x squared, so plus 5x squared. 5x times -3, that's -15x, or minus 15x. Then we have 4 times x, that's plus 4x. Then we have 4 times -3, that's -12, so we have minus 12. Last step, we want to combine our like terms. So we have 2x squared terms, and we have 2x terms. So one possible function with these zeros would be x cubed, -3x squared plus 5x squared, that's positive 2x squared, so plus 2x squared. -15x plus 4x is -11x, or minus 11x, and then minus 12. So again, this polynomial function, which is also a cubic function because it's degree 3, would have the real zeros of -4, -1, and +3. And to verify this, since these are real zeros, we can graph this function and verify these would be the x-intercepts of the graph. So here's the graph of the function that we just found. Notice how we have an x-intercept of -4, -1, and +3, which verifies our work. Okay, I hope you found this helpful.